Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devview.com. In this lesson, we're going to talk about handling exceptions that occur within our applications. We'll discuss what can go wrong, why things go wrong, and how to build resilient applications that are impervious to crashing through the use of C#'s try-catch block statement. So when the compiler catches a data type mismatch or an unresolved reference to a class or some malformed C# instructions, it'll refuse to compile your C# code into a .NET assembly until you fix the problem. These type of errors are called compilation errors, and that's not what we're talking about in this lesson. However, there are other types of errors that happen during runtime, or in other words, they happen when the compiled .NET assembly is actually in the act of executing. And honestly, there are countless number of reasons why you could encounter an exception while the application is running, depending on the kinds of things you're trying to do in your application. And many times, these things are outside of the direct control of the software developer. So for example, if your application can't read or write to disk because a folder or a file is missing on disk where it expected to see it, it could trigger a runtime exception. Or maybe the file's corrupt, or maybe the network access to that resource is unavailable, or attempted perhaps to access a database and it couldn't find something in the database that it needed, a table, a column, whatever the case might be, because the structure has changed of the database out from under the application. All of these things and many, many, many more could cause the absolute failure of your application. And the user will see a nasty error message at runtime, and they'll in frustration say, the developer. So in some cases, the developer may have not even foreseen that could have potentially been an issue. And so if they didn't see that it could be an issue, they couldn't have accounted for it. Maybe the developer, for example, allows the users to type in a country, but the user misspells the country name. Now, maybe they did that intentionally or unintentionally. Perhaps they maliciously use numerical characters instead of alpha characters. But as a software developer, your job is to make sure that you account for all of these possibilities. A friend of mine was fond of saying that 80% of all code exists to solve 20% of all the potential problems that could happen in your application. So generally, software developers should be pessimistic regarding the reliability of everything outside of their control, whether that be input from an end user, any connection to a network, to the file system. Anything that the developer cannot directly control should be held in great suspicion. So again, if you rely on a file or a network resource, you should treat it with great suspicion. If you rely on the user to type data into your application, definitely treat that with great suspicion. It's absolutely evil, okay? So this is the software developer's equivalent to driving defensively. Always code defensively, which means you are always looking for problems all around you all the time. Now, the way that the C# developer codes defensively, or one of the ways in which they do it, is through the use of a try-catch block. And I'll demonstrate that in this lesson. Up to this point, we've been reading or actually writing files to disk. This time I want to read a file to disk. We use the same file class like we've used previously. And notice that I already have a using statement for system.io, so it finds it. And this time I want to use the read all text instead of the write all text. And here, let's just go ahead and set this example up. Notice that I've already got a project created called Handling Exceptions. Please pause the video and catch up with me if you like. But here we go, string content equals file.readAllText. And then let's just, for the sake of argument, hard code a location. I'll put this at lesson22./example.txt, and then we'll do console.writeLine the content, and then finally console.readLine, like so. Great. All right, so far so good. And now here, I just want to demonstrate that this actually will work. So you can see that I created off my root a lesson 22 folder with example.txt in it. Let's go ahead and run the application and show that there is actually text in that file. It's just a quote from Mark Twain. And now that we've got it working correctly, let's break the application by giving it a fake name, just by removing the E on the end of example.txt. And now you can see that we get an exception. This is a file not found exception, was unhandled. And so I'll tell you what, let's do this. Let's stop the application. That's what the developer will see while they're debugging their application if they were to run across this issue while they're building the application. But what if we were to build a release version of the application by changing the solution configuration and then selecting build solution? Now we're going to go out to our projects directory, and I'm going to act like an end user and actually attempt to use this application outside of Visual Studio, so outside of the debugging environment, just to see what the end user would see if they ran into this exception at runtime. The name of this is handling exceptions. All right, there you go. And let's go into the bin directory, into the release folder, and I'm going to double click the handling exception, and whoops. Notice that I get this ugly little message here, and it's trying to help me figure out what happened, and I get all this text here with all this ugly information, just spewing out all this information that an end user probably would have absolutely no idea what the issue was. Although we can read here near the very top that the problem is that it couldn't find the file lesson22/example with no e.txt. Now, a very observant user might be able to look at this and figure it out if they stared at it for a while, but most users are going to be scared off by this, and I don't blame them. So we ideally would like to make sure that the end user never sees anything like that whenever they run our application. So again, Windows will then close the application, notify you if there is a solution available. There's just a mess going on there, and we want to protect our end users from this mess, from ever seeing this. So what we can do is actually wrap a try statement, a try and a catch around this. So we'll do this, and there's a couple different ways to go about it. I'm just going to take the easiest approach to begin with. And what I might do is just go ahead and let's switch back to the debug configuration and run the application. Now, you may have noticed that the application ran briefly and then went away. And the reason it did was because we ran this, we hit an exception here, the catch statement kicked in, there's nothing defined in the catch statement, and we continued on. What if we were to move this to right there? We would at least see the application now run for a little bit, and we would see no output. So still not an ideal situation, but at least we're not seeing any exceptions. Let's go one more step with this and say let's actually catch the exception that occurred. So here we're going to catch an exception call that we're going to call EX. Now, exception is the most general type of exception that can be thrown. What we're going to look at in a few moments are very specific versions of exceptions, but this is the most general version, so that at least we can see what the problem is, and we might do something like, you know, there was a problem, something like that, and even we could provide a description of the problem, so the message from the exception. So let's go and run the application, and at least this time, you know, at least we're giving the user some feedback here. There was a problem, could not find the file lesson22/example.txt. Okay, so that's better. Again, it would require an observant and slightly more technical end user to be able to resolve this issue on their own, to say, wait a second, I wonder if that file might be named something different here on my own hard drive, as they traverse through and look for the file, and they're like, oh, I see what the problem is. There's no E on the end of example. All right, that's asking a lot of your end user, but that at least is a step in the right direction. At least we're giving them some clue as to what the issue is. Now, really what I would like to do is account for all the possibilities and be a little bit more specific. So if I were to hover my mouse cursor over this read all text where the issue seems to be mostly, you'll see that we've only been looking at the return value and the input parameters for a call to a method. But notice below that there's a list of possible exceptions that could occur. Also, if we were to go to system.io.file.readAllText, so let me just copy this, pop open, and let's go to Bing. We're basically going to be searching through Bing here for system.io.file.readAllText. That should help us find an article in MSDN that has a full description of this method. You'll see that there's two overloaded versions. We're using this first overloaded version of it. And then if we were to scroll down and past some of the initial information, there's a list of exceptions. And it would provide us some scenarios why that particular exception might happen. Like a security exception, the caller doesn't have the required permission. All right. The path is in an invalid format. Interesting. File not found. The file in the path was not found, and there's also a directory not found. Interesting. Okay, so maybe the path was too long, or maybe we provided a null value. So there's a lot of things that could potentially go wrong whenever calling this method, and as developers, we really need to the extent that we can, account for all those potential situations, at least the ones that make sense. So, for example, I could rewrite this code example to begin catching some of those specific examples. So, for example, let's take a look here. Let's first of all make sure that the directory exists, and then if it does exist, then we'll check to make sure the file exists. And so then if the file and the directory exist but we're still getting exception, then maybe we let it drop off to this most generalized exception here. So I'm going to start from the most specific case and then work my way to the most general case. In this case, I think the file not found exception is probably the most specific of the ones that we're going to work with, and then we'll catch the directory not found exception, and then if that doesn't work, we'll just print out whatever the exception was. So here I might do something like console.writeLine and say there was a problem. And then give it a specific, make sure the name is, a name of the file is named correctly. Should be example.txt, all right. And then we can do something similar here and say there was a problem, make sure that the name of the directory, directory. Make sure the file, make sure the directory c:/lesson22 exists. All right, something like that. And remember, we're getting the red squiggly. Why? Well, because we either need to add another backslash here or add the @ symbol there. Remember that from earlier? Okay. So let's go ahead and test our application, and I'm going to set a breakpoint here whenever we hit this line of code so that we can watch this execute. All right, so let's go ahead and step over, and it looks like it found the file not found exception, and so we will see there was a problem. Make sure the name of the file is named correctly. All right. Then let's go out and let's rename this to lesson 22A, and I think we're still going to get the same actually exceptions. So maybe that's oh no, we did get the directory not found exception. Good. Okay. So in this case, we'll see that error message. Make sure the directory lesson 22 exists. All right. And then for any other exception, maybe there's a permissions issue on the computer. Maybe there's a the file is corrupt somehow and we can't read from it. We would get this last catch-all where we catch just the general exception and print it to the user. Okay? So at any rate, the key to this is that we check the most specific exceptions first and the most general or generic exceptions last. There's also one other item I want to add here, and that's a finally statement. And this is where we would write any code to finalize, which might mean setting objects to null, closing database connections. All right, but this code is going to run no matter what, and so we're just going to go console.writeLine. Closing application now, like so that we can see that this code will run regardless. It's just that one last chance as a developer to clean up our mess before we stop the execution of the application. So, and you can see that now represented here by closing the application now. Great. Now you might look at this and you might think to yourself, okay, great, I'm going to use this try-catch around everything in my application. Every single line of code in my application, I'm going to wrap it with a try-catch. So I'll just take every method and I'm going to blindly just copy and paste everything in there. And that's definitely a strategy that some people take. It's a little bit lazy, quite honestly. Some developers have done that, but they're often ostracized by their end users for providing very cryptic error messages. So if we were to leave all of these off and just wrap everything and just only show the exception EX, we would just be saying, hey, there was a problem here, figure it out for yourself. That's not really advocating on the part of the user, right? We're not protecting the user. Furthermore, we might be tempted to provide some type of debugging information for ourselves as developers. Sometimes you'll see some error codes pop up that no human could be expected to understand except the guy who originally wrote the application. The reason developers do this is because sometimes they take that exact approach where they just say, hey, we're going to forget about the user, I'm just going to wrap everything in a try-catch, and it'll pop the error message to me, it'll float back to me, I'll fix the problem, and everything will be okay. But again, this catch-all is convenient to the developer, but it's really frustrating to the end user, so you shouldn't do that. You should strive to put the same amount of attention into protecting your user from having these sorts of issues and protect them from having to guess at what to do next by simply helping them fix the problem. Tell them specifically if you possibly can. If you, the developer, can fix the problem, or at least you can point the user in the right direction, then that's awesome. You should do that. But if you can't, well then at least try to identify the exact nature of the problem and then ask the user for the type of input that you would need as the developer to fix the issue. You don't want to leave your users feeling stupid that they did something wrong. You want them to feel empowered, and you want them to feel like your application is well built and it considered them whenever you were building it. So that's what makes your application polished. It's what users expect, a reliable experience with no surprises. All right. So to recap this lesson, we talked about a number of different things related to exceptions that can happen essentially anytime that you, the developer, are not completely in control and you're accessing things outside of your boundary of control, outside of your domain. You need to wrap those in a try-catch and be thoughtful about the types of exceptions that you'll be handling, listening for specific exceptions that a particular method could raise, and it's easy to find out. All you got to do is hover your mouse cursor over it, or you go to MSDN and you find the call, that method, and you look for, like we did, all the potential exceptions that could happen, and then, you know, be reasonable about it, but then write the code necessary to handle those exceptions and protect your end user. We looked at the try, the catch. We looked at catching the exception and then using certain properties of the exception, like the message property, to print out to the user what the issue was. We could also use this to log the error, even send it to a centralized logging service like Application Insights that's available from Microsoft Azure to report back to the developers what the issues were. And then you can use the finally code block to clean up any connections you have to file systems, databases. You can set objects equal to null and go ahead and remove all of your references and be very explicit about that before you shut down the application. Okay, so hopefully that was helpful. This is a great lesson in building resilient applications, giving the users the kind of experience that they would expect whenever things go wrong in your apps. All right, so we'll have one or two more lessons and then we're done. We'll see you in the next lesson. Thank you.